Okay, let's take a look at Unit 4. And we're first going to start off with monomials and polynomials. And it'll be adding, subtracting, multiplying, and dividing. So let me bring up the tablet here. So a monomial is where you got one term, like 5x squared. And back there. Polynomial is when you have one or more terms. So that's a monomial. 7x plus 3 would be a polynomial because it's got one or more terms. Terms are separated by pluses and minuses. This is specifically also a binomial, but just generally these are all polynomials. Now if we look at 5x squared plus 2x squared, what they mean about adding and subtracting monomials is you add or subtract like terms. Like terms is we have the same variable to the same power. Since these are both x squared, then to combine these, I add or subtract the numbers in front. 5 plus 2 is 7, so we got 7x squared. If I had 8x to the third minus 4x to the third, subtraction is the same way. As long as they're like terms, they both have the same variable to the same power, you add or subtract the numbers in front of them. 8 minus 4 is 4, so we got 4x to the third. Now the difference between that and polynomials is, let's say I got 5x squared plus 7x minus 1 plus 2x squared minus 4x minus 3. First off, you get rid of these parentheses. These parentheses aren't doing anything because there's no numbers in front of them and or no minus. So that gives us 5x squared plus 7x minus 1 plus 2x squared minus 4x minus 3. Now to combine together like terms, same variable, same power. Here's x squared, here's x squared. So 5 plus 2 is 7, so we got 7x squared. Here's 7x minus 4x. 7 minus 4 is 3, so we got 3x. And then we got negative 1, negative 3, which gives us a negative 4. And that would be our answer. Now subtracting is very similar to that. We still get rid of the parentheses. This first set of parentheses isn't doing anything. So I got 4x to the third minus 7x plus 2. Now a minus out in front of your parentheses, this flips the sign of everything inside. So this is going to flip the sign of the positive 2x squared, the positive 3x, and the negative 1. So the positive 2x squared becomes a negative 2x squared. The positive 3x becomes a negative 3x. The negative 1 becomes a positive 1. So I'm going to have 4x to the third. Notice that there are no other x to the thirds, so I can't combine those together. Then minus 2x squared. There are no other x squared, so I can't combine anything. Here's a x, here's an x. Negative 7x, negative 3x is negative 10x. Here's a 2 plus 1, which gives us 3. And that'd be your answer. Now this is, by the way, standard form. Standard form is when your terms are arranged from largest power down to smallest. X to the third, x squared, x, no x. You should always write it in standard form even if the problem doesn't indicate that. Now for multiplication. Let's say I have 5x times x minus 3. We have one term here, and we got two terms inside. This is a distributive property. We're going to take this 5x, this term that's out in front. We're going to multiply it times our first term, and we'll multiply it times our second term. So we're going to take 5x times x, and we'll take 5x times negative 3. Now 5x times x is 5x squared. And 5 times negative 3 is negative 15, and then the x carries along. Now this gets into a little bit into 7.4, simplifying integer exponents, working with integer exponents. But if you have x to a power times x to a power, then what you do is you add together your exponents. So you got x to the 3 plus 5, or x to the 8th. When I multiplied x times x, these were both x to the first power. So I added the exponents. 1 plus 1 gives us our 2. Now let's take a look at 3x minus 2 times x plus 5. We're going to multiply these together. Notice here we got two terms in this parentheses, and we got two terms in this parentheses. So we're going to take our first term in the first set of parentheses, the 3x. We'll multiply it times each term over here. We'll take our second term, the negative 2, and we'll multiply it times each term over here. So we're going to have 3x times x. I'm following these lines to see what to multiply together. 3x times x. We'll take 3x times 5. We're going to take negative 2 times x. And we'll take negative 2 times 5. This is commonly known, when we're talking about two terms and two terms, a binomial times a binomial, as the FOIL method. Though I like to follow lines in class and to show people that. This says we multiply our first terms together, 3x times x. We multiply our outer terms, the 3x times the 5. The outer in terms looking at the entire problem. The inner, negative 2 times x. That's the inside terms here. And then the last terms. Last terms in each set of parentheses. Okay, 3x times x is 3x squared. 3x times 5 is 15x. Minus 2x. Negative 2 times 5 is negative 10. No matter where you are in math, you always combine together like terms. 15x minus 2x is 13x. Minus 10. And that would be our answer. Nice part about the line method is it does not matter what it looks like. I'm not going to actually multiply this together. But if I had this problem, you wouldn't need to think, well, because how do I apply the FOIL method? Now you apply the line method. Take each term in this set of parentheses, the x squared, multiply it times each term over here. Then take my second term, the negative 7x, and I'll multiply it times each term over here. And then I'll take my last term, the 2, and multiply it times each term over here. So it does not matter what it looks like in terms of multiplication. Using the line method, you just follow the line and see what to multiply together. Now I'll just start showing it. X squared times x squared. Following the red lines, x squared times 5x. And x squared times negative 1. Then you go to the blue, and you'd have negative 7x. And you follow in the blue line, negative 7x times x squared. Negative 7x times 5x. And negative 7x times negative 1. And then follow in the purple, 2 times x squared. 2 times 5x, and 2 times negative 1. And then work this, combine like terms, and that'll give you your answer. Now that's multiplication of polynomials. Clear this off. A little bit all over the place here. They talk about dividing here, and we're going to look at dividing. But then down here on 7.5 it says divide a polynomial by a monomial. So we're going to start off with that to see how in the world to do that. Pen. We already mentioned that if you got x to a power times x to a power, you add your exponents. 2 plus 5 gives us 7, so that'd be x to the 7th. If you got x to a power over x to a power, what you do is you subtract a smaller exponent from a larger one. So 9 minus 2 gives us 7. And we're going to have x to the 7th where a larger exponent was, which was on top in this problem. And then we put a placeholder of 1 down below, but x to the 7th over 1 is x to the 7th. Along the same lines, if I have x to the 3rd over x to the 5th, if you got x to a power over x to a power, you subtract smaller exponent from larger one. 5 minus 3 is 2, and we're going to have x to the 2nd power where our larger exponent was, which was on the bottom. And then we put a placeholder of 1 up on top. And that would be our answer. Now this is division. So up here, when they're talking about dividing monomials, that's how you divide a monomial. They have to be the same variable, and then you do that. Now that also gets into that integer exponents. This kind of all runs together, so the properties goes along with that. And then also leads into this, divide a polynomial by a monomial. Oftentimes it's, what do you cover first? You have to have this knowledge before you do this, but then you have to have this knowledge before you do this. It's almost circular in some forms. Where do we use that at? Well, let's say we have x squared minus 7x plus 2 over x squared. A polynomial divided by a monomial. What we do here is if you've got a single term, a monomial, in your denominator, you split this into separate fractions. So you can put x squared over x squared minus 7x over x squared plus 2 over x squared. Now x squared divided by x squared is 1 minus, we've got a fraction here, I put a 7 up on top. This is a x, which is the same as x to the first power. If you got x to a power over x to a power, remember you subtract a smaller exponent from a larger one. 2 minus 1 gives us 1, so we're going to have x to the first power where our larger exponent was, which is on the bottom. And here, I can't really simplify anything of that, so this becomes 1 minus 7 over x plus 2 over x squared. The question often becomes, why would you want to do this? Simplified form typically means a single fraction. This is a technique you see in the calculus course. In a calculus course, you have to split them up into separate pieces like this so you can take something called a derivative or an integral of these. Let's show one more. Let's see, a to the 5th b squared plus ab to the 3rd over a squared b squared. We still have a single term down here, a monomial. So we're going to split this in separate fractions. So I put a to the 5th b squared, our first term, over our denominator, a squared b squared plus ab to the third, and I'm going to go ahead and write a to the first just so we can really see that first power, over a squared b squared. Okay, so we're going to handle each one of these separately. We'll look at the a's first. We got a to a power over a to a power. Subtract the smaller exponent from the larger one. 5 minus 2 is 3. So we're going to have a to the third power where the larger exponent was, which is on top. Now the b squared and b squared are the same, so those are going to cancel. And we'll put just a placeholder of 1 there temporarily. Now the a's over here. We subtract smaller exponent from the larger one. 2 minus 1 is 1, so we're going to have a to the first where our larger exponent was, which is on the bottom. Now our b's. Subtract the smaller exponent from the larger one. 3 minus 2 is 1, so we're going to have b to the first where our larger exponent was, which was on top. So that gives us a to the third plus b over a. And that'll be our answer. Okay, let me clear that off. And then we'll look at division where you got 2 or more terms on the bottom. So let's say we got x squared minus 5x plus 6 over x minus 2. This is called long division or polynomial division. And I'll set it up in this form. Now we're going to look at the first term of each side, what goes up on top. So we're going to look at the x and the x squared. And you ask yourself, what times x gives you x squared? And that'd be x. Now whatever you put up on top, you're going to multiply by what's out in front. So we're going to take x times x minus 2. X times x is x squared. X times negative 2 is negative 2x. Now we're going to subtract this line, which means flip signs. So this positive x squared becomes a negative. This negative 2x becomes a positive 2x. Some of you may do that in your head, but I can't show you steps in my head on the board here very well, so I'll actually write it out. But that's what happens when you subtract. It flips signs. X squared minus x squared drops away. Negative 5x plus 2x gives us negative 3x. And then I'll bring down the plus 6. Some people are taught to only bring down what they need. Some people are taught to bring everything down. I was taught to bring everything down. It's like you're starting a brand new problem. Again, we only looked for the first term in each. Decide what goes up on top. So we'll look at the x here and look at negative 3x. And you ask yourself, what times x gives you negative 3x? That'd be negative 3. Whatever we put up on top, we're going to multiply by what's out in front. So I'll take negative 3 times x minus 2. And that gives us negative 3x. Negative 3 times negative 2 is a positive 6. Now we're going to subtract that line, which means flip signs. So negative 3x becomes a positive. The positive 6 becomes a negative. Negative 3x plus 3x drops away. 6 minus 6 gives us 0. So our answer here will be the x minus 3. Now let's take a look at another example where we'll have a remainder and see how to handle that. So let me clear this off. Let's see, x minus 2 and x to the third plus 7x squared minus 8x plus 1. Again, we'll take a look at the first term of each side, what goes up on top. You ask yourself what times x gives you x to the third, and that'd be x squared. Whatever we put up on top, we're going to multiply by what's out in front. So I'll take x squared times x minus 2. X squared times x is x to the third. X squared times negative 2 is negative 2x squared. Now we're going to subtract that line, which means flip signs. So positive x to the third becomes negative. The negative 2x squared becomes positive. X to the third minus x to the third drops away. 7x squared plus 2x squared is 9x squared. And again, I'll bring down everything to the right. It's like starting a brand new problem. Then we look at first term of each. Sidewall goes up on top. We ask ourselves what times x gives us 9x squared, and that's 9x. Now again, whatever we put up on top is we're going to multiply by what's out in front. So I'll take 9x times x minus 2. 9x times x is 9x squared. 9x times negative 2 is negative 18x. But then we're going to subtract that line. So flip signs. So this becomes negative, this becomes positive. 9x squared minus 9x squared drops away. Negative 8x plus 18x gives us a positive 10x. And then I'll bring down to plus 1. Then again, we look at first term of each. Side goes up on top. You ask yourself what times x gives you 10x, and that'd be 10. Whatever we put up on top, we multiply by what's out in front. So I take 10 times x minus 2. And that gives us 10x minus 20. And we're going to subtract that line, which means flip signs. So this positive 10x becomes a negative. The negative 20 becomes a positive. 10x minus 10x drops away. 1 plus 20 is 21. Now, there's nothing I can multiply times x that give me 21. So, when you get to that point, what you have down there is called your remainder. And we'll put a remainder over what we're dividing by. There's different ways books represent that. They could do R and then 21. Some will take 21, put over what we're dividing by. Just different ways to write that. But that means your remainder. I'm going to clear that off. And just make sure nobody's on. There we go. Let's see, that was adding, subtracting, multiplying, dividing, and simplifying. 7.4, we're talking about simplifying integer exponents. Scientific notation, let's talk about that, and then we'll get into factoring. Scientific notation looks like this. Got a single digit, one through 9. Can't be 0. And then you have some more digits here, times 10 to the power. What you do here is you drop off trailing zeros. Okay, so that's our form of scientific notation. If I had a number look like this. Wanted to change that to scientific notation. Well, if I were to put a decimal here, it'd be clear. You can always put one clear at the end. Now our goal is we want just a single digit in front of the decimal. So what we're going to do is we're going to move this decimal point 1, 2, 3, 4, 5, 6, 7 places to the left. So this is going to be 3.93, and that drop off the trailing zeros, times 10, and then how many places you moved it is the number you put here. 3, 6, 7. Now the question always comes in, is this positive or is this negative? Well, my wife had a pretty good chemistry instructor use this guideline. She said, is this a large number? If it is, then this should be a large number here. 10 to the 7th means 10 times itself 7 times, which is a large number. If I put negative 7, that would be a very small number. So again, the positive is larger, the negative is smaller. So it kind of makes sense when you think of it in those terms. Now if I had this problem here. First off, notice that this is a small number, isn't it? And we want our scientific notation to be a single digit, 1 through 9, not 0. So we're going to need to move this decimal 1, 2, 3, 4, 5 places to the right. So this would be 5.12 times 10. We moved it 5 places. If I put a 5 here, this is going to be a large number. This is a small number. So I'll put a negative 5 here. And that would be our scientific notation. Now some problems require you to go the other direction. For example, if I had 7.12 times 10 to the 6. Well, here's our 7.12. This indicates we need to move our decimal point 6 places in one direction or another. Since it's a positive 6, and this is a large number, we want to move it to the right. So move it 1, 2, 3, 4, 5, 6. This will be our new location. And we have to put zeros in here for these missing digits. So this is going to be 7, 1, 2, and then 4 zeros. 1, 2, 3, 4. So 7,120,000. Along the same lines, here, I need to move my decimal point 2 places. And since this is a small number, I need to move it to the left. So it'll still be a small number. Well, move it 1, 2. So this will be our new location of our decimal. We have to put a 0 here for that missing digit. So this can be 0.0253. And that's our scientific notation. Let me grab a drink here. And we'll talk about factoring. We're going to cover the 5 main factoring techniques. First one is GCF. And that stands for greatest common factor. Our next one is grouping. And this is when you have 4 or more terms. Our next one is PSD. And this is when you got the form x squared plus bx plus c. Then we have the key number. When you got the form ax squared plus bx plus c. And then the dots, which is difference of 2 squares. This is when you got 2 terms with a minus between them. These are your 5 main factoring techniques you'll run across in algebra. There's a couple more, the sum and difference 2 cubes you can read about in the book and see an example of it. But you really don't see them that often in problems. These are the main ones you run across. Let's say I have 8x minus 10. This is GCF. When we got numbers, we look for the largest number divides into both of these numbers. So we got 8 and 10. The largest number divides into both of those is 2. To factor means to write as a product, but it also means specifically to divide out. So 8 divided by 2 is 4, so we got 4x minus 10 divided by 2 is 5. And that would be your answer. Okay, let's take a look at another example. 7x to the third plus 14x. Number-wise, I'm looking at 7, 14. Largest number divides in both of those is a 7, so I can bring 7 out. Now here we have 3 x's and here we have 1 x. We want to factor out the most x's we can, but we can't bring out 3 x's if this one only has 1. So in this case, we're going to bring out a single x. It's always the smallest exponent. And remember, x here is the same as x to the first power. Okay, again, factor means to divide out. 7 divided by 7 is 1. We had 3 x's, we took 1 x away. So we're going to have 2 x's. It's kind of like you visualize it. You have 3 x's sitting on the table. Somebody comes and takes one of your x's, you got 2 x's left. Plus, 14 divided by 7 is 2. And we had 1 x, and we took that 1 x away, so there's no x's left. So our answer is going to be 7x times x squared plus 2. Now for grouping, let's see here. So we got 2ac minus 2ad plus BC minus BD. First off, we look for the GCF. We always look for the GCF, and there isn't any. This is 4 or more terms, so the only method to really try is factoring by grouping. Now, factoring by grouping, we group the first 2 terms together, and we group the last 2 terms together. Then you look at each of these separately. If I look at the first group, they have a 2 and an a in common. So I can factor out a 2 and an a. And that leaves us c minus d. For my second group, they have a b in common. And that leaves us c minus d. Now our goal with grouping is to get this parentheses the same as this parentheses, which they are. So I'll factor out a c minus d. Now, what goes in your second set of parentheses, you go up to this previous step, cross out to c minus d's, and what isn't crossed out is what goes right here, which is 2a plus b. And that's our answer. Let's take a look at another example. Let's say we got x squared plus 5x minus 3x minus 15. First off, GCF-wise, there isn't any. All 4 terms have nothing in common. 4 or more terms, I think factor by grouping. So group the first 2 terms together and group the last 2 terms together. Now the first 2 terms have an x in common, so I can factor an x out. And that gives us x plus 5. The last 2 terms have a 3 in common, and the first term is negative, so I'll factor out a negative 3. When your first term is negative, you always factor out a negative. And that gives us x plus 5. Again, remember, factor means to divide out. Negative 3 divided by negative 3 is a positive 1x, or just x. Negative 15 divided by negative 3 is a positive 5. Our goal is to get these parentheses the same, which they are. So I'll factor out the x plus 5. Again, to see what's left, you can go up to the previous step, cross out what they have in common, and What isn't crossed out is what goes right here, which would be x minus 3. And that'd be our answer. Let me clear that off, and then we'll look at the PSD method. Okay, so we're going to have x squared minus 6x minus 16. There is no GCF. Grouping is 4 or more terms. Now I said the PSD is a form of x squared plus bx plus c. I didn't really mention what b and c were, but basically you have x squared, x, no x, and there's no number in front of your x squared. X squared, x, no x, there's no number in front of our x squared. That's what tells us the PSD method. With the PSD method, we take the number at the end, ignoring signs. Number at the end is 16. That's our constant term. And we're going to come up with 3 columns. P column, S column, and D column. P stands for product, S stands for sum, and D stands for difference. With the product, we're going to write down all products to give us 16. We got 1 times 16, 2 times 8, 4 times 4. The sum column, we're then going to add these together. 1 plus 16 is 17, 2 plus 8 is 10, 4 plus 4 is 8. With the difference column, we're going to subtract the smaller number from the larger number. 16 minus 1 is 15, 8 minus 2 is 6, 4 minus 4 is 0. Now, the number we're looking for is a number in our middle term. So we're looking for 6. 6 is right here, which means we're going to use 2 and 8. PSD is always the same way. You always have an x here, you always have an x here, and then whatever 2 numbers you find, you put right here. Last thing we have to determine is what our sign is going to be. Well, the larger number in the P column we're using 2 and 8, so the larger one is the 8, will always be the same sign as the middle term. The middle term here is a minus. So this will be a minus. Now, the number we circled is in the D column. D for different signs. It means one will be positive, one will be negative. Since the 8 was negative, then 2 has to be positive. And that's our answer. Let's take a look at another one. So we got x squared minus 10x plus 24. Again, it's PSD because we have x squared, x, no x. There's no number in front of the x squared. So we take our number at the end, ignoring signs. So we'll be working with 24. And then come up with our columns again. We write down all products, give us 24. We got 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now we're going to add these. 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. 4 plus 6 is 10. Subtract them. Smaller from larger. 24 minus 1 is 23. 12 minus 2 is 10. 8 minus 3 is 5. 6 minus 4 is 2. Number we're looking for is a number in our middle term, which is 10. So I'm going to use this one right here. So we use 4 and 6. Now our larger number we're using 4 and 6. The larger one is a 6. Will always be the same size as the middle term. Middle term is a negative. So that'll be a negative. The number I circled is in the S column. S for same signs, both positive, both negative. Since this one's negative, this one has to be negative. So I have x minus 4 and x minus 6. And that's our answer. Now this particular one had 2 10s. You may have been wondering, well, how did you determine which one to use? If your sign here at the end, on the last term, the constant term, is negative, the negative will always be in the D column. If your sign on your constant term is positive, that'll always be in the S column. So I knew it wasn't this 10 because since this was positive, it had to be in the S column. So this guideline here will help you if you got two of those numbers. Okay, let's look at key number. Let's see, 14x squared minus 9x plus 2. Let me double check that. Let's try that again. Minus 11x plus 2. Minus 4x minus 7x plus 2. Okay, that looks good. There is no GCF because all three terms have nothing in common. Grouping is 4 more terms, so that doesn't fit. PST is close, but PST says you have an x squared, x, no x, and there's no number in front of the x squared. We have a number in front of our x squared. Key number says ax squared plus bx plus c. Specifically what we're looking for here, don't worry too much about what a, b, and c represent. Typically they're integers. But we're looking for x squared, x, no x, and there's a number in front of the x squared. X squared, x, no x, and there's a number in front of x squared. If this fits the form. So this would be key number. Key number, some books call it the AC method, comes from the fact that you're taking the numbers before your x squared, the a, you multiply it times the number at the end, the constant term, your c. So we're going to take 14 times 2. Now, we would still ignore signs. If that was a negative 2, we'd still go with positive 2. And we got 28. Now, we're still going to use the PST table. We're just going to use it differently. Write down all products give us 28. We got 1 times 28, 2 times 14, 4 times 7. We're going to add them. 1 plus 28 is 29. 2 plus 14 is 16. 4 plus 7 is 11. We're going to subtract them. 28 minus 1 is 27. 14 minus 2 is 12. Excuse me. 7 minus 4 is 3. Still looking for the number in the middle, which is 11, which is right here. So we're going to use 4 and 7. And what we're going to do with the key numbers is a little bit different. Before we just wrote down our answer. Here we're going to rewrite our middle term using these two numbers. So 4 and 7. Now our notes and our signs still hold true. Our larger number we're using, which is 7, will always be same sign as the middle term. So we're going to have a negative 7x. Number I circled in the S column. S for same signs. So if the 7 is negative, the 4 has to be negative. And we'll have a minus 4x. Going backwards, negative 7x and negative 4x should give you the negative 11x. Then I'm going to factor by grouping. So I look at my first two terms, and I see what GCF is. Largest number divides in both those is 7, and they both have an x. So that gives us 2x minus 1. Now you might say, well, where'd that 1 come from? You take the 7 away and take the x away, there's nothing left. Remember, factoring means dividing out. 7 divided by 7 will always give you a 1. Now here, I want to factor out what they have in common. They both have a 2, and my first term is negative, so I'll factor out a negative 2. Remember, if your first term is negative, always factor out a negative. And that gives us 2x minus 1. Now our goal is to get these parentheses the same, which they are. So I'll factor out a 2x minus 1, and that leaves us 7x minus 2. And that's our answer. Let's take a look at another problem. Say we got 32x squared minus 4x minus 1. It's still key number because we've got x squared, x, no x, and there's a number in front of your x squared. So again, with key number, we take our number at the beginning times the number at the end, ignoring signs. So 32 times 1 gives us 32. We're going to write down all products give us 32. We got 1 times 32, 2 times 16, 4 times 8. I think that's everything. Add them. 1 plus 32 is 33. 2 plus 16 is 18. 4 plus 8 is 12. Subtract them. Smaller from larger. 32 minus 1 is 31. 16 minus 2 is 14. 8 minus 4 is 4. Number we're looking for is the number in the middle term, which is 4, which is right here. So we're going to use 4 and 8. Again, we rewrite our middle term using those two numbers. The larger number that we're using 4 and 8, so larger one's the 8, will always be same sign as the middle term here. So we're going to have negative 8x. Number I circled in the difference column, D for different signs. So if the 8's negative, the 4 has to be positive. And you should be able to go backwards here and just check on your sign. Negative 8x plus 4x gives you negative 4x. Then we want to factor by grouping. Now the first group here, the largest number divides in both those is 8, and they both have an x. So that gives us 4x minus 1. Now this next group doesn't have anything in common. But you can always factor out a positive 1. That doesn't change anything, still leaves us 4x minus 1. But we're factoring something out. Again, our goal is to get this parentheses same as this parentheses, which they are. So I'll factor out a 4x minus 1. To see what goes in your second set of parentheses up here, you go up to your previous step, cross out the 4x minus 1s, what's the same, and then what's left goes here, which would be 8x plus 1. And that'd be our answer. Okay, one more technique. One more example. Then I'll open up to any questions you have. Let's say I got 16x squared minus 9. GCF, there isn't any. Grouping is 4 more terms. Well, that doesn't apply. PST and key number are both 3 terms. These are 2 terms. Our last technique, 2 terms with a minus between them. 2 terms with a minus between them, that applies. So we're going to try to write it as something squared minus something else squared. We always set it up in this form. And then you take a look at each individual piece and you ask yourself what times itself gives you that. For example, it's 16. 4 times 4 gives us 16. The x squared, x times x. And the 9, 3 times 3. Now, if you're able to rewrite it in this form, that's when you can use difference 2 squares. Now I'm going to label what's in the first set of parentheses as F for first. And I'll label what's in the last set of parentheses as L for last. And this is just a formula. F plus L times F minus L. After you identified your F and your L, you just plug them in. So we're going to have 4x plus 3, and we'll have 4x minus 3. And that's our answer. So I'm going to go ahead and stop the video here and then answer any questions you have.